Thanks for joining, everyone. Just give us a few moments for everyone to get onto the webinar, and then I shall kick off. Okay, so thank you for joining our AWS Sumo Logic Kubernetes Immersion Day workshop. Looking forward to having a chat to you about Kubernetes and some of the ways that we can help you solve some of your observability challenges with Sumo Logic as well. So one of the things we want to be able to do here is provide some customizable experiences to help you discover and learn some of the various options which are available on AWS. Help prospects and customers drive into the services and solutions which are on offer, and some hands-on time and guidance from solution architects and trainers for some of your use cases, and being able to actually jump on, get your hands on the kit, and have a bit of a play with some live data as well. So today's agenda, the welcome, which is now. Welcome everyone, thank you for joining us. We'll go through a bit of an introduction to AWS and Sumo Logic, cover off Kubernetes on AWS, and then we'll go into some details about Sumo Kubernetes Observability, and then jump into some hands-on labs. And then we will also have time at the end for some Q&A, and any particular questions you have, I'll be happy to do my best to answer them. So today's speakers, we have a late scratching, unfortunately, of Sneh from AWS. So you'll be hearing mostly from me, Eddie Thompson. I am lead solution engineer for APAC at Sumo Logic. So I'll be covering off Sneh's material as well. Not as familiar on that side, so bear with me and I shall do my best. Oh, hang on. It looks like we've got Sneh's here, but not as a panelist. Okay. 1 second. Right, panelist.
Perfect. I think.
Are you able to? Can you talk now, Sneh?
Are you able to hear me now?
Yes, I can hear you. Excellent.
Okay. Sorry about that.
No, it's okay. It's obviously it had you coming through as an attendee rather than a panelist. That's why we couldn't see you. Okay. Well, fantastic. So we do also have with us today Sneh from AWS. Like to introduce yourself.
Thank you, everyone, and sorry for the delay. I wasn't able to, come on the time. But welcome, everyone, and excited to be here. My name is Snehanshu Baisare. You can call me Sneh. I am AWS Partner Solution Architect based out here in Auckland, New Zealand. So before we dive deep into the solution, I would like to give you a quick overview of the Kubernetes and where the AWS fits in, and a high-level overview of the integration of AWS with the Sumo Logic. So let's start with the Kubernetes. So as we all know, Kubernetes is an open source container management orchestration platform, and it is well known for its portability. Okay, for the fact you can run the Kubernetes across multiple environments. But the number one reason that we are hearing from our customer is the ability to deploy and ship the code faster. It's built to help you run your containerized application at a scale, and comes equipped with the features and the functions to build a proper distributed applications using the 12-factor application pattern. Example of that is Kubernetes allow organizations to deploy and manage applications like a platform as a service, batch processing workers, and microservices in the cloud at a scale. So how does it actually do that? So from a very high level, 10,000 feet view, it provides through an abstraction layer created on top of the group of the host, which helps development teams to let Kubernetes manage a function of the host, including the load balancing, monitoring, controlling the resource consumption by a team or an application, limiting resources consumption, and leveraging the additional resources from newly added hosts to the customer and other workflows. Can you go to the next slide, please? So Kubernetes does many things, including simplifying the deployment and the management of the containerized application, and it is backed by the cloud native computing foundation. Kubernetes allows you to configure and run the containerized application at a production scale and integrates the drivers to configure the networking and storage for your application. In addition, operation team need to ensure that the workload are deployed in a secure manner without exposure to the known security vulnerabilities. This further increases the operational overhead of running the Kubernetes on your own. All of this effort does not really move your business forward, and our customer want to focus on the application and the ideas that would allow them to deliver the new products to their end users faster. And this is the reason why a lot of our customers have came to rely on the Amazon to handle the undifferentiated heavy lifting of security and operating Kubernetes at a scale. Next slide. So which underlying cloud platform to choose? Meaning we know AWS is backed by low latency, highly available, redundant infrastructure with the multiple regions and the availability zones within them. The quality of the underlying cloud platform really matters. The speed, stability, scalability, and the integration with the platform all impact the quality of the application that you build and how much work you have to do it by yourself, and ultimately how happy your customers are. Your customers perceive the performance of your application based on how quickly the new features are introduced and whether your application is down when they actually needed it the most. So ultimately, underlying cloud platform matters because at the end of a day, that's a compute infrastructure you and your customers would be using. Next slide. Today, based on CNCF, Cloud Native Cloud Foundation study, 65% of the organization chooses AWS to run their containerized application. So why do they really choosing AWS for running their EKS? Number one reason, through AWS EKS, normally the cumbersome steps are done for you. For example, creating the Kubernetes master cluster, configuring the service discovery, Kubernetes primitives and networkings. Existing tools will more than likely work through the EKS with minimal modifications, if any. Second important reason, with the Amazon EKS, the Kubernetes control plane, including the backend persistent layer and the API servers, is provisioned and scaled across the various AWS availability zones, resulting into the highly availability and eliminating the single point of a failure. Unhealthy control plane nodes are detected and replaced, and patching is provided for the control plane. The result is resilient AWS managed Kubernetes cluster that can withstand even the loss of the availability zone. Third important reason is organizations like you can also choose to run EKS on an AWS Fargate, which is the serverless compute engine for the containers. With the Fargate, there is no longer need to provision and manage the servers. Organizations like you can specify and pay for the resources per application. Fargate through application isolation by design also improves the security. And the last reason is, of course, as a part of the AWS landscape, EKS integrates with various AWS services, making it easy for the organizations to scale and secure applications seamlessly from AWS Identity Access Management IAM for the authentication to Elastic Load Balancing for load distribution, and the straightforwardness and the convenience factor of using EKS can't be understated. Next slide. So what I'll give a quick high-level overview of the integration of EKS with the Sumo Logic, and then AD will go into further details about the integration. So from very high level perspective, there are two main things. One is the control plane and one is the worker nodes. So for the worker nodes, Sumo Logic is leveraging the open source technologies like Helm, Fluent, Bit, Prometheus to push the logs and metrics to Sumo Logic. And for the control plane logs, Amazon EKS logging provides the audit and the diagnostic logs directly to the EKS control plane to the CloudWatch logs into your account. These logs are forwarded to Sumo Logic via the Lambda functions. Once you have configured the collection of the logs, Sumo Logic app for the Amazon EKS can be installed and alerts can be configured. AD will dive deeper about it later in the workshop today. And with that said, I'm here to answer any of the questions. Over to you, Eddie.
Thank you very much, Snape, for that introduction and covering off the details about AKS. So, yeah, as Snape mentioned, he's here to answer questions. So, if you have anything that you wish to pop into the Q&A chat while I'm talking, that's fine. And we will have some specific time for Q&A after the lab session as well. So, what I'm going to talk to you a bit about today is observability with Sumo Logic and end-to-end observability, how we can sort of let you know what's going on within the state of your application and within your sort of Kubernetes clusters as well. So when we're talking about monitoring and we're talking about observability, monitoring is when you're sort of collecting data and you're looking for a known set of events. It's letting you know when something is wrong because it's outside the bounds of the parameters which you've configured. Observability is something that's sort of come from control system theory, but it's basically about externalizing the state of an application through the data that we make available. So it's making that data available so that we can understand what is happening, and it enables you to understand what's actually going on in your application, not just something has gone wrong. So the big thing about the Sumo Logic workflow that's really powerful for Kubernetes is it provides an intuitive workflow and it automatically discovers your application and infrastructure topologies and entities. It allows you to visualize what the service relationships are and provides you sort of like a GPS style navigation to be able to go from alerts, investigate the topology, have a look at the entities and identify some root causes as well. So one of the things that we try to sort of bring to the table is advanced analytics. So observability, various sort of observability workflows. We tend to go through this monitor, diagnose, troubleshoot flow. And there's a few different things that we sort of bring to the table here. So when we're monitoring things like outlier analytics, so looking across your various time series data and saying, hey, this is outside the norm. Rather than having fixed thresholds, being able to say, this is a statistical anomaly, we're going to alert on this. Predictive analytics, being able to see that based on current trends, you're going to have a problem soon. And our global intelligence benchmarks, being able to sort of detect rare and unexpected events in your environment based on sort of golden benchmarks across a customer cohort which you are in. So I'm seeing something which is unusual based on the benchmarks in other environments. And that's sort of on the monitoring side. When we're getting into diagnosis, we're looking to narrow down narrow down where we actually are bringing things in. So what's the where of the problem that we're having, and that's when we can use things like log reduce for pattern analytics in your logs, saying, hey, you've had a huge spike in these sorts of log events, or if you have a look at the relationship between these two log files, there is a statistical relationship between a couple of different JSON keys that may identify where the problem is. Time compare, really, really powerful to be able to detect your drift from the normal based on the last hour, based on the same time yesterday, based on the same time last week. Are we seeing something which is anomalous to our normal behavior? And troubleshooting, log compare, once again, really, really powerful to be able to answer that question, what changed? Everything was fine an hour ago. Show me the comparison between my log signatures now and an hour ago. Have I got a heap of messages which have disappeared, or have I got a big spike in something which wasn't there an hour ago? Makes it really easy to sort of identify those unusual causes. I apologise for my voice. I've got a cold at the moment, so I'm a little bit croaky. And Root Cause Explorer. This is something that we'll dig into a little bit further in the labs, but it's a really, really powerful set of machine learning based tools which allow you to identify visually and graphically possible root causes based on entity and service relationships within your AWS infrastructure and your Kubernetes infrastructure as well. So this is a great quote, but we replaced our monolith with microservices so that every outage could be more like a murder mystery. There's been a huge explosion in complexity when it comes to modern applications. There are a lot more moving parts. Microservices have meant that there is a relative sprawl, and without the right tooling, it can be really difficult, particularly if you're the engineer on call at 3 a.m., to know where to start and how you actually sort of are going to investigate and deal with that outage and find the root cause as effectively as possible. So one of the things that sort of changed in AWS sort of architectures is AWS encourages the use of separate AWS accounts to help manage costs, to give independent administrative control, and also you might have different security settings, different settings for different regions, depending on the needs of a specific app. Now, once you're in a certain account and region, there are multitudes of services that customers can use to run their apps. And within each service, for example, EC2, Elastic Compute here, if you have multiple entities or instances that corresponds to, these all have their own data monitoring as well. The problem with all of this complex hierarchy, it often leaves data silos where it can be difficult to get a clear picture of your overall service health across the regions and accounts. So you see here 21 unique AWS services in use by a typical AWS customer. So what's the challenge? Visibility across AWS account region, service, and across the account region and service hierarchies. There's a lot of services to monitor. Troubleshooting becomes complex. So troubleshooting complicated by service dependencies can be compounded by needing to analyze metrics and logs using ad hoc queries. If you've got data silos in your AWS account and regions and service hierarchies, it gets difficult to have a clear picture of what's going on across your application space. So the solution that we bring to the table is AWS Observability. It unifies your visibility, and Root Cause Explorer accelerates your troubleshooting. So we give you a nice, easy to install, easy to deploy, easy to discover option to have all of your AWS accounts and the relative logging and metrics pulling into one place, and making it really easy to drill down from accounts to regions to namespaces and entities within those. So pivoting a bit to Kubernetes more specifically, and some of the observability challenges that exist. What's the main thing with Kubernetes? It's highly ephemeral. Containers come and go, workloads scale up and scale down, and it can be difficult to keep up with ever-changing deployments. There are many different data streams. The metrics are hugely important. The logs are always hugely important. But you're also adding in things like tracing data as well now. You may be getting kernel level security detections from tools like Falco or other sort of eBPF based tooling. If you don't have the appropriate metadata models and tagging, it becomes really difficult to be able to draw these complex service relationships. And it's difficult to get the big picture and to zoom in. So can I go from the high level and see what my overall service health is looking like? And can I zoom in down to a specific pod, the containers within, seeing the logs for that particular service or container? Is it really easy to get down to that level of specificity and identify root causes? So how does Sumo help solve for these challenges? We auto-discover your environment and allow you to view your Kubernetes data through some different lenses and help you work with the mental model that you have for Kubernetes. So namespace views, service views, not just a traditional infrastructure sort of node-based view. We deal with all the various data sources, so we can collect structured and unstructured data. We collect metrics, we collect your traces, we collect all of your logs. We apply a consistent metadata model to them and allow you to search across and correlate this data. And as I mentioned, so the big picture, because of how we tag this data, the metadata model, we give you that ability to go from the high level and also zoom into really specific detail to identify root causes. So where are you deploying a Kubernetes app today? Do you have a roll your own cluster? Are you already using EKS? How are you managing the infrastructure of that application? Do you collect logs from your infrastructure currently? How do you manage that? Do you have visibility of all the entity dependencies within your application? How much time do you spend administering on your monitoring tools themselves? How many tools do you use on a daily basis? Is problem resolution slower than you would like? What do you think causes those slowdowns? How much time do you spend reconfiguring your tools when you do a new deployment? It's a difficult question. There's a lot of things out there. There's a lot of tooling, but at Sumo, we're a cloud native SaaS platform. We make it really easy to get that data from your Amazon environment, from your Kubernetes environment, and have you up and running in minutes and hours, not weeks and months. It's something that you can get up and running really quickly and be deriving real value from pretty quickly. So Snow touched on the data pipeline earlier. I'll go into a little bit more detail here. So at Sumo, we use a completely cloud-native computing foundation governed observability collection model here. So for the logs, we have a fluent bit deployment, a daemon set deployment. So each node has fluent bit running to act as the log router. So it collects all of the logs as they're written to standard out, grabs the logs from systemd, and we pipe those through to our enrichment deployment. So currently this is running on FluentD. This will be migrating to OpenTelemetry in the near future. But basically, this is where this metadata comes into play. So we get every single log message and make sure that is stamped with service, deployment, namespace, in addition to some of like the more traditional infrastructure tags, nodes, pod, container. For metrics, we use Prometheus as a Prometheus operator running in the cluster, does that auto discovery, make sure that we're getting all the metrics from Kubelet, from KubeState, and being able to see what's going on within the cluster on the metrics side of things. Once again, this is all forwarded through that enrichment pipeline. It all gets tagged appropriately as well. Now, Falco, on the security side of things, this is an optional workflow. So Falco is an open source kernel level anomaly detection tool for Kubernetes, basically letting you know if there is some security things that are going on in your cluster. It's a great way to be able to surface that information. That's an optional add-on. You don't have to install it, but it is there. And if you're not running any security tooling for Kubernetes, it is definitely worthwhile. The other thing, which is not in this diagram, which should be, is trace collection. So when we deploy our Kubernetes collection, we also have trace collection using OpenTelemetry to collect those traces as well. And once again, all this is sort of forwarded through that pipeline, tagged, and then forwarded onto Sumo Logic. And that can all just be deployed as a Helm chart. And we'll give you a little bit of a taste on how to do that towards the end of the labs as well. So the Sumo Kubernetes app, it's the primary app that we'll be working with in the class today. It's got many features and benefits. The ability to manage and monitor multiple clusters. It works with that centralized metadata enrichment, which means it's really easy to filter down to what's relevant to you. Gives you visibility into the worker nodes of a Kubernetes cluster. But as I mentioned, allows you to investigate that data in a way that makes sense to you, using that sort of mental model that you have, use it for namespace, for deployment, for service, rather than just a pure infrastructure view. There's a heap of out-of-the-box pre-built dashboards, which are dynamic and filterable based on how you're exploring your data. And Cloud Native Computing Foundation standards and out-of-the-box security features as well. So during the lab activities, we'll install this app and we'll play around with some of the pre-built dashboards as well. Now, the Kubernetes app that we have is consistent. So no matter whether you're using a roll your own version of Kubernetes, if you're using Amazon ZKS, excuse me, it looks completely the same. But we do also provide control plane apps. So this is sort of like an add-on that works alongside the main Kubernetes app, gives you visibility into the cluster master nodes, and that's whether it's open source or a managed service. So in the case of EKS, you can install EKS, and we grab those logs from CloudWatch rather than from the cluster directly, as Amazon is managing the control plane on your behalf. Now, that's not the only app that we have. So the Sumo app catalog has over 200 integrations and apps available. So there are dozens of Kubernetes apps for things like Aqua and Twistlock on the security side. When you install an app, it appears in your personal folder, and you only need to install each app once per account if you share them out. So that's enough of me talking away about Kubernetes and our solutions. So I think what everyone's hoping to do today is be able to get their hands on the tools, so to speak, and we'll log into the training environment, and we can get on with doing a couple of labs. So, what I will get you to do today is we'll go to service.sumologic.com and you'll get to the Sumo login screen. So, service.sumologic.com. Now, the login I will get you to use is training plus analyst. And where you see the 3 hash marks or pound signs, choose a number between 001 and 999. So once you've chosen a number, please drop it into the chat box on Zoom so people can see which number you have chosen. So you might choose training plus analyst 123 at sumologic.com. And then the password will be logs 2022 exclamation mark. So it's a capital L for logs and 2022. Okay. So I'll give everyone a moment to log in. And then we shall proceed. Now, I think here's one I prepared earlier. So I have already logged in myself, which is good. If you're having any trouble logging into the environment, just let us know in the chat box as well. So, first of all, we are going to install the Kubernetes app, and you can install this in your own account. Your own login. So, what we're going to do is in the left-hand navigation bar here, we're going to go down to App Catalog. So we click on the App Catalog, and you can see there's various applications in here. Now I could search. I can see Kubernetes is popular. It's up the top here. But if I click on Kubernetes, I can see various associated apps here. So here's the Kubernetes app that I'm going to install. If you see any of the apps here which have got the little blue tick mark in the top, this means this was an app which was developed by one of our partners. So, for example, Aqua Security, they've built this app. StackRock's built this one, but this one here was built by Sumo. So I can click on this. It gives me a bit of a preview of what's there, and I can click Add to Library. Now, for the Falco log source here, we're going to use asterisk, Falco asterisk, and for the events log source, the same, asterisk events asterisk. So and I click Add to Library. May have already been installed, so I'm going to add my name here for the app name. There's a question from Jason, and no, there is not a cost when adding to the library. So everything you see within the Sumo app catalog is an integration which is provided as part of the service. So there are no additional charges for using our AWS Observability or using the Active Directory app or the Kubernetes app that we're installing today. So the charging model for Sumo is very straightforward. It's all based on the volume of data that you send us. You burn down you have a credits allocation which you use there, but that is very straightforward. So the amount of data is the only thing which determines your costs for Sumo. So no charges, no additional charges for any of these integrations that you see in the app catalog. So we've added in the values and we've clicked Add to Library, and that has installed the application. So now we can view the dashboards that we have installed. So we're going to go to the black navigation bar. We're going to click on this personal folder icon, and then we're going to click on the Kubernetes cluster overview dashboard. So I can click on my personal folder here, and I can see I've got Kubernetes-Eddy, which is the one that I installed. And I can go down and see Kubernetes cluster overview. I can click on that dashboard. A question from Anil here. So applications within Sumo can be installed for a single person, but they can also be shared out with the organization. So if you're the administrator, you may wish to configure and install some applications which you think are going to be useful for your team, and you can share those out under the admin recommended folder so everyone can see them and they're shared across the account. Or you might have applications which are only relevant to a particular team, or they might be some security data which is only looked at by the security team, and that's all securable by role-based access control as well. So having a look at these dashboards here, this is giving us a heads-up view of what's happening in our cluster. So we can see things like CPU, memory, disk space, drop network traffic, the total number of CPU cores, and the total amount of memory. I can see the count of nodes that I have running in my cluster and the number of pods that I have over time. I can see nodes which are in a ready state, nodes in a non-ready state, pods that have failed, pods that are running, and any pods which are unschedulable. And I'm also able to see things like the top CPU consuming pods. So what's running relatively hot, or what's using the most memory. So I'll give you a few moments to play around and have a look at this dashboard by yourself and see what you might find is interesting. So by default, we're looking at all of the data we have, but we can also go down to a specific cluster if that is more interesting to us as well. So that was looking at the cluster overview dashboard. You can see that there are many other things. So I might be interested in seeing what's going on with core DNS within my cluster. Or I might be looking to have a look at the HPA scheduler, or possibly some security overviews. So I've got Falco running in this cluster here, and so it can give me a list out of what my top rules that have been triggered are, where they've been triggered by priority, which processes, which users, or which pods have been triggering these services. So this is just looking at the dashboards directly. And it's a useful thing. It can give you it can give you a lot of information, and also it can be used for constructing dashboards of your own. So you can always always open a query, and if you wish to adjust the way that it's shown, or if you wish to add it to another dashboard of your own, you can do that as well. It's all very open to be able to mix and match. And also, when you're talking about tracking at the method and function level, we're looking sort of more at the Kubernetes infrastructure side. But if you are using Sumo Logic tracing, absolutely, then you're able to, with OpenTelemetry, instrument your application so that you can see your service calls and relationships there. But this is more looking at the Kubernetes infrastructure itself. So rather than viewing the dashboards directly, there's a really powerful view that we have for Kubernetes. So this is how we navigate with Explore. So what we're going to do is click on New, and then we're going to open up an Explore window. And then we're going to explore Kubernetes by the service view. So I'll jump back over to here. So I click on New, or I can, if I'm on the front page here, I can click on Explore here, but I'll click on New, go down to Explore. And this is opened up. So this is some tracing information here. This is looking at real user monitoring. But what I'm going to look at is Kubernetes service view. So this is how I am able to go through some various different clusters. And this makes it really easy when I have multiple clusters to explore what's going on. So we had a question about FluentD and Falco to be installed by the customer. So we have when you deploy the Sumo Logic Kubernetes integration, there's a Helm chart, and you just need to fill in a few values to be able to connect it up to Sumo, and then it automatically goes and deploys all of the infrastructure that is required automatically. So it's not something that you need to do manually yourself. So as I mentioned, when I am exploring via service view, I can see here I've got a cluster, and I can see the namespaces which exist within the cluster, and I can see. So this is the namespace for the Sumo Logic collection. So I can see there is metrics pods, there's FluentD pods, there's Prometheus pods, services, sorry. So, but within here, I can then see the pods that are related to that particular service. And this is a really powerful thing, because if I swap over to an infrastructure view, which is a node-based view, I can still see my clusters, but once I've dropped down the clusters, I can only see the nodes. And the nodes have loads of different pods on them, but I'm only seeing this in an alphabetical order. So I can see a FluentBit pod here, and there might be a FluentBit one here as well. But when I went to that service view, I can very quickly identify all of the pods which are related to that particular service. And the same thing that goes through a deployment. If I'm troubleshooting a deployment, I don't want to have to be going through all of my various nodes trying to track down where a pod is, because I know that there is a deployment for FluentD. And I can get my data for what's happening for the entire deployment very quickly by clicking on it at the deployment level. And I can see all of the pods which are related. But if I want to drill down to one particular pod, I can. I can see all of the pod info. I can see the metrics for that particular pod, and I can see the most recent logs that have been happening for that pod as well. So it makes it really, really simple to go from that high-level cluster overview all the way down to the logs for a specific pod. And this service view and deployment view, really, really helpful for troubleshooting compared to a traditional infrastructure-based view. So that was going through a few bits on the dashboard. So now we'll pivot a bit and talk about how we can find, solve, and prevent failures using Root Cause Explorer. So in this workshop, we're going to be using the Root Cause Explorer to accelerate troubleshooting and pinpoint the root cause for incidents in the apps of Travel Logic, a fictional online travel agency that uses AWS services. So the Root Cause Explorer is an add-on to the AWS Observability Solution, and it helps on-call staff, DevOps, SRE, infrastructure engineers, excuse me, infrastructure engineers, and accelerate their incident resolution, minimize the downtime for their apps running on AWS. The Root Cause Explorer works by tracking metrics from things like CloudWatch, from Kubernetes, from our tracing data, and establishing a baseline for what normal looks like for that metric. And then then when you have non-ordinary events, unusual spikes, these can be then correlated in the Root Cause Explorer as events of interest. So we've already set up metrics coming in to the Sumo account here. So we've got metrics coming in from CloudWatch. This can come in from Kinesis streams natively to Sumo. So Kinesis metric streams are great because they're lower latency than the traditional scraping from CloudWatch. And also it's fewer scraping events to your CloudWatch APIs, less likely to have account limiting errors, and it's lower latency. So it's one of those things which is just generally all around a lot better. So big fan of Kinesis streams for metrics here. So I'll demo how to access the Root Cause Explorer. So, oops. There's a few different ways to get to it, but we can click on New and go down to Root Cause, and that will open up the Root Cause Explorer. You might get a note saying, "Hey, this is the new thing that you've opened up." Now, the thing about the Root Cause Explorer is when you have no filters, it can be a little bit noisy. So it takes a little bit to use, but the important thing here is these golden signals that we're tracking. So throughput, error, bottleneck, latency, availability, load, and success. Now, some of these are leading metrics and some of these are trailing, indicators. Some of these are leading indicators, some of them are trailing indicators. So you might have load or bottleneck as a leading indicator, and then you might have error or latency as a trailing indicator. So some things happen early, some things happen later. As I hover over a particular bubble here, now the bubbles show me two things. A, the duration, so how long this is happening. So the x-axis here is time. And then we have on the y-axis here, the volume of drift. And when we talk about drift, we're saying how far is this from the normal baseline? So I can see I've got a MongoDB bottleneck here, and that's really, really far away from the baseline. I've got a lot of other sort of load events here. Now, this is showing me everything, all of the stuff. So normally it's a little bit more interesting to add some filters. So I can see here I've got data coming in from AWS and host metrics, Kubernetes metrics, and application services. So this is trace metrics. So I'm going to add a filter in. So if I go, so I'm going to region here. Actually, what I'll do, I'll show you this via the AWS Observability. So I'll click on AWS Observability, and this shows me my overview dashboard. I can see I've got multiple AWS accounts here. So I'm going to click on prod. And I'm going to select US East 1 as my region. So this is going to take me down to a region level dashboard. Now, I can also here access the root cause explorer, and this is adding in some filters for me. So it's only looking at this particular account. So I can then also say, hey, let's open this in the root cause explorer to give me the full UI. But you can see here now in my filters, I've got an account and a region filtering my data. And I can see here that it's a bit less cluttered. So I can see what's actually happening. The other thing I can do here is change from the bubbles to a Gantt chart. So sometimes this becomes a little bit easier to view as a timeline. So having a Lambda resource error, which may trail into a DynamoDB bottleneck, which is then leading to a CPU bottleneck on an EC2 instance. And then finally, seeing that there is a load balancer spike in 500 error counts. And I can see here that looking at my time shift of 1 day, so doing that time comparison, that wasn't happening. So this is a problem that's occurred, and I can see that, yeah, it's not something that's happening a week ago. It's not something that happened yesterday. It's only happening today. And yeah, we can sort of trace back from that load balancer to high CPU to a DynamoDB bottleneck. And it looks like there's a config problem on a Lambda resource. Could be the underlying cause there. So this is how the root cause explorer allows you to show service relationships, but also time-based relationships. So being able to group things that are happening at the same time. So some bottlenecks leading to spikes and errors. But because we're tracking the relationships between the entities, we can see, yeah, here's what's happening with this particular load balancer. And this has got a service relationship to these EC2 instances to this database table. Really, really powerful stuff. But yeah, being able to filter down that data quickly and efficiently is the important thing, because without that ability to filter, you get a lot of noise in there. So that's the really important thing that we need to be able to do. So Travel Logic welcomes all the new hires. So we're going to play the role of a DevOps specialist in Travel Logic, an online travel agency. The agency has a website and a mobile app that their customers use to book tickets. The agency has a DevOps team, including analysts, software developers, and security engineers. So, excuse me. A DevOps specialist is supporting a mission-critical application on AWS that uses the following services: an application load balancer. It's got hosts running on EC2 and a DynamoDB. The end users experience the outage. The application, they're getting 500 errors in the US East one in the last 24 hours. So, being a DevOps specialist, your challenge is to troubleshoot and rapidly isolate the root cause. So, we should already be logged in. But then we're going to click Explore By and select AWS Observability. Then we're going to select the prod account and the US East 1 region. So just as I ran through there before, so I'll just clear these out. We're going to start new, explore, and we're going to go to AWS Observability. From there, we're selecting the prod account, and we can see the regions that are associated. And we've got the US East 1 region. And so I can see some errors here on the application load balancer. We can go in and investigate where we're seeing our requests come from, our request by load balancer. We can see where we've got the 500s coming through and spiking. So identify the error or the spike. So we're in our AWS Observability and we've gone to prod and US East 1 region. We're going to make sure the time range is set to 24 hours, and we're going to select the AWS application ELB namespace. So we've got time frame 24 hours. We're in prod US East 1 and application ELB. You can investigate. So, can we see a spike? So I can see some events of interest, those drifts. So we can see those spikes there. If we click on a particular metric, it highlights it. If you shift click on it, it removes. So if you just want to highlight something, single click. If you want to remove it, shift click. So the question, what caused the outage? So we can open this in the root cause explorer. We can see that error, but we're not seeing anything else. And the reason for that is because of the filters that we currently have. So we're only looking at an account, a region, but we're also looking at a namespace. So we're only showing the application ELB here. So if we added in EC2, Dynamo, then we're able to follow back from the CPU bottleneck to the DynamoDB. So we can see that there's a throttle event here, read throttle events happening at the same time as that application load balancer. So that database table getting throttled is resulting to high CPU on the EC2 instance, and it's manifesting itself as those 500 series errors on the load balancer. But all of these things are able to be correlated to that similar time period. So that's how we can use the root cause explorer to go and explain how we can get from a spike in a metric to an underlying cause really efficiently. So that's how we can get to the actual root cause, and it's really helpful when you're going through a post-mortem, being able to say with a fair bit of confidence that you've been able to identify and remediate the issue that was caused, and it's not just that there was some 500s and something got rebooted and it's all good. So it's particularly good on this historical context too. It's not just while it's happening, because we computed across all of these metrics. You can drill in after the fact to sort of do that root cause analysis and put some things in place so it doesn't reoccur. But yeah, it's a very, very powerful feature, and once again, it's something that doesn't cost you extra to use. So if you're ingesting these CloudWatch metrics to be able to alert on things like high CPU or memory usage, or that you've got errors on your load balancer, this is a value-added service that we're providing to you with Sumo, the machine learning, the monitoring. This is not something that you have to pay additional for. Once you're ingesting those metrics, we're sort of computing this data for you. So it's something that you can utilize, and you're not getting charged extra for it. So it's a really powerful monitoring feature. So, bit of a bit of a recap. Root Cause Explorer embodies 5 concepts: abnormal spikes, they're indicators of underlying problems; context and correlation of spikes, the time range of an incident; connections between resources and services, so entity relationships. Is this server part of a load balancer group? Earlier spikes, they are closer to the probable cause; and associated log exploration to identify the true root cause. So to run through the Root Cause Explorer, find a time range of interest based on the incident timeline. See the connection as per the root cause guidance. So we know it was happening in a particular region, add those filters. Apply different context filters to further isolate the root cause, and then view time series and logs to analyze the true or actual root cause. So this is one of the last things I'll sort of touch on here is Helm for installing the Kubernetes cluster, Kubernetes cluster collection. So one of the things you need for this is an access key. So within Sumo, there's a couple of ways to get to this. So if you go to manage data and collection, up here there is a link for access keys. This can also be found under administration and security. Now, if I wish to use the Helm chart to install Sumo Logic, I need an access key for it to be able to create resources within Sumo. So I can create a new access key, say Eddie Sumo Logic, and it gives me an access ID and an access key. Now, you need to copy these down and keep them safe, and the access ID will be visible, but the access key is only generated once. Once you've seen that, if you don't copy it down, you need to create a new one. You can't be shown it again. If you want to search, you can. So I can see mine there. You can deactivate a key. or you can delete them. But once you've got your key, you can install the Kubernetes collection using the Sumo Helm chart. And the only two things you really need are that Sumo Access ID and Sumo Access Key. So we can go to Sumo Logic K8's collection, and you'll see it on GitHub. So you see here the addition of Traces collection via OpenTelemetry. For the installation steps, I can go to the current version of the chart and installation with Helm. So it gives me all the details on what to do. But as we can see here, to install Helm upgrade -- install my release, Sumo Logic, access ID, access key, and what you want to call your particular cluster. And that will go and create the resources in your Kubernetes cluster, but it will also create the resources within Sumo Logic itself. So what that means is when we go to collection, you'll be able to see a cluster such as this. It'll show up as hosted, but you'll see the metrics destination, API server control plane, the events destination, logs destination, traces destination. And then once that's there, you're able to install the Kubernetes app, view the dashboards. Now, as a best practice, we recommend using a values file when adding this configuration. So anything that you want to change, you create a values.yaml file and add in the various variables that you wish to keep for a particular cluster. And as you can see in the details, you can then just point it to -f values.yaml. So that's just the values that you are changing or adding, rather than having to have a whole heap of extra switches in line, which gets cumbersome. And it gives you something which is easy to keep track of, what the current state of your configuration is. Now, I think we're getting pretty close to time here. Let's just see. So, time for Q&A. I can see that people have been asking some questions along the way, which Ashutosh has been helpfully answering. Does anyone else have any questions that they would like to ask?
Eddie, there's one question regarding the availability of the platform, this training one for the participants.
Yes. No. So yes, the training cluster will be up there. So yeah, you can keep using this this password for the rest of the month.
So it will be available for a month or something?
The current password will be available for a month. Yes.
Yep.
The rest of the month.
Thank you. Yep.
But as this is a training environment, it is routinely reset as well. So if you having fun building some dashboards and anything that you wish to keep, I do recommend that you export them because that environment does get wiped fairly frequently. Any other questions? You don't need to upgrade the account for to be able to create an access key. So yeah, either go to the collection page and click on access key, and then you can go add access key here, or under administration security and access keys. Now, access keys have the permissions associated with the user that that creates them. But yeah, if you see anything, so where it says upgrade account here, that's just a standard thing about. It's basically just to request your account manager to get in contact with you because you might want to purchase more credits because you've got new use cases, etc. But yeah, there's no requirement for that to be able to create a access key. Snow, I can see there's a question there. Is there an AWS credit available for this session? I don't know. So if Snow has the answer to that, I will let him jump in.
Joseph, I didn't actually understood your question. What do you mean? For the environment, you require AWS credit, or is it for something else? If it is environment related question, to try out the demo, yeah. So I reckon AD has already answered that. Like this environment is going to be available for you guys for the rest of the month, so you can use that.
For Sumo specifically too, if you wish, anyone can go to sumologic.com and you can click on start free trial. And using a business email, you can choose where your instance is going to be, and you can get that up and running in minutes, and then you can use that. That's a 30-day trial account, and you can use that to to send data from your own Kubernetes cluster if you wish to try that out as well. So if there are no other questions, might wrap it up a little bit early, give everyone some time back in their day. But thank you very much for taking the time to join us today. I hope it's been informative, and yes, the recording will be shared. So thank you very much for taking the time with us today. Really appreciate it. So I'll see you all later. Thank you very much.
Awesome. Thank you all.